Morning, students. We are live now. Nathan and Navya has joined. Good morning. Is my audio and video clear? Good morning. Is my audio and video clear? Yes. So thanks for the confirmation. Okay, let's wait for others to join. So Matthew has also joined. Himanshu has joined. So I can see slowly you people are joining. So let's start today's class without wasting any time. Today we are going to do tangents and intersecting chords. This is this chapter is a continuation of circles chapter. So whatever concepts we have done in circles, so those concepts also we will be using in this chapter. So tangents and intersecting chords. So first few properties of tangents and intersecting chords I will tell you, and while doing questions, whichever properties of circles are there, I will just explain you while doing the question itself. So before I won't explain the properties of circles. So along doing the questions, I will be explaining you the properties. So first of all, what is a tangent? So the line you can see on my screen also. So circles are there. So the line which passes through the circle exactly having one point of contact with the circle. So here this is a tangent. This is a tangent. This line you can see it has only one point of contact with the circle. Here if you see in second figure, AP is a tangent. One point it has. PB is a tangent. So tangent is that line which has one point of contact on the circle. Now few properties are there. First one, if this is the radius of the circle, this is the radius of the circle. You have to remember radius and tangent, they are perpendicular to each other. Radius is perpendicular to tangent. So this property you have to remember while doing questions many times. We will be using this property. Radius is perpendicular to the tangent, or tangent and radius both are perpendicular to each other. So second property, you can see the second figure here. From same point P, we have drawn tangent AP also and tangent PB also. When two tangents, they are drawn from same exterior point, they are equal in length. They are equal in length, so you can write tangents from same exterior point. So here P is the same point, exterior point. From P only these two tangents are drawn. So tangents from same exterior point are equal in length. Are equal in length. What does it mean? That it means AP is equals to BP. AP is equals to BP. Let's learn third property. So this is a property of a circle which is known as angles in the alternate segment. Angles in the alternate segment. are equal. So let's understand this. What is this property? So if we have angle between tangent and chord, so tangent is this line. So I can show you here the ST line because it passes through the circle and it has one point of contact. So here ST is tangent. ST is tangent and PQ. If you see here, PQ is chord, line PQ is chord because chord is that line which is inside the circle and it has its end point on the circumference of the circle. So PQ is chord, PQ is chord and PR is also chord. PR is also chord. So it is a line which is inside the circle. So here the property says angles in the alternate segment are equal. So how to recognize these angles? So segment, first of all, I'll tell you if this is a circle and I have one chord. So chord divides the circle into segments, two segments. This is this is segment. You can say this is minor segment. This is minor segment, and this is also segment. This part is full. This part. This is major segment. So chord divides the circle into two segments. So here also if in the given figure if you see the figure which is given to us, you see two segments are there. First is this one, this is segment and the other one is this one. So angles in the alternate segment are equal. So how to recognize these angles? If the angle is between chord and tangent, if the angle is between chord and tangent, so that angle you have to see. So here this is the angle, angle QPT. If you see angle QPT, this is between the chord and tangent. See here if I start, so this angle I am talking about, this angle is between chord and tangent. So PQ is the chord and PT is the tangent here. If you see this angle, if you see this angle, see this angle will be equals to the angle in the other segment. You just have to move along the end points of the chord. You just have to move along the end points of the chord and where they are meeting, that particular angle will be equals to this angle. Suppose here this angle is X. So this angle is also equals to X. Angle PRQ. So this angle QPT is equals to angle PRQ. Just you what you have to do, you just have to move along the end points of the chord. Let's see one other angle also. Here if you see PR and SP is also there is angle between PR and SP. PR is chord and SP is tangent. So this angle I am talking about. If you move along the end points of the chord. So they are meeting at one point Q. So this angle. So here this angle, angle SPR, it's equals to angle RQP. So these two angles are equal. So if this is 30 degree, this is also equals to 30 degree. So this property while doing questions we will solve. There are few other properties. So while doing questions, I'll be explaining you those properties. So let's start with the question. So first of all, let's do MCQs questions. So questions will be same. You should know the concept. So I am just going to start with MCQs. So try to draw the figure wherever it is possible. So first question you can see from a point Q, the length of tangent to a circle is 24 centimeters. So always try to draw figure if possible. So this there is a circle, there is a circle, and they have mentioned from a point Q, the length of tangent to a circle. So Q point lies somewhere outside the circle because from here we are drawing, from here we are drawing one tangent to a circle. The length of tangent to a circle. So tangent is that line which is passing through one, which is having one point of contact. So this is a tangent I have drawn. So the length of this tangent is 24 centimeter. The distance Q from the center. Suppose this is the center of the circle. This is O. I am considering as O as the center of the circle. The distance O, the distance Q, the distance of Q from the center of a circle. So distance of Q from the center of a circle is 25. So radius we have to find. So here let us say this is point P is there. The point of contact is P. So we have to find the radius of the circle. So I am just joining this with the tangent. OP is the radius. So length of OP I have to find. So how we will do? We'll make use of the first property which I told you. Radius and tangent they are perpendicular to each other. So I told you one property, radius and tangent are perpendicular. So radius is perpendicular to tangent. So therefore we can say angle OPQ is equals to 90 degree. So overall here we can see this triangle, triangle OPQ. Triangle OPQ is which type of triangle? Triangle OPQ is right angle triangle. It is right angle triangle. And in right angle triangle, we can use Pythagoras theorem. Yes, so Pythagoras theorem we can use. So Pythagoras theorem is square of the hypotenuse is equals to perpendicular square plus base square. So we will use this. So hypotenuse is that side which is opposite to right angle. Hypotenuse is that side which is opposite to right angle. So here OQ is hypotenuse. So 25 square is equals to perpendicular means radius we can consider OP square plus base square. Base 24. So square of 25 is 625. This 24 square I'll shift to this side. So square of 24 is 576. So OP, the square also I'll shift to this side. This square I'll shift to this side. It will become square root. So this is equals to 49. So 49 the square root is 7 centimeter. So OP is equals to 7 centimeter. So 7 centimeter option A. So another thing also shortcut also I'll tell you because here we are doing MCQ so you should know why I have shown you because this concept you can use in subjective type of questions also so that's why I solved. But you can use shortcuts also. So here we know this here we will be getting a right angle triangle. So if the hypotenuse is 25, so distance of this point from center will always give us hypotenuse. This line will always be a hypotenuse. This thing you have to remember. So sometimes students will get confused and they will write PQ as hypotenuse. PQ is not hypotenuse. Always the central line will be the hypotenuse in these type of questions. So you just have to remember this is the hypotenuse. If hypotenuse is given to us and we know 7, 24 and 25, this is Pythagorean triplet also. This is very common Pythagorean triplet in many questions they use it. So directly also without solving you can do it because we know 7, 24, 25 is a Pythagorean triplet. Let's do next question now. So similar type of question. Question number 2. What's given to us from a point which is at a distance 13 centimeter from the center. So one point is there which is at a distance of 13 centimeter. So from center if distance is given, if I am getting any triangle that will be always hypotenuse. So one point is there which is at a distance of 13 centimeter from the and one point is there which is at a distance of 13 centimeter from center of a circle whose radius. So radius is also given to us. Radius is 5 centimeter. The pair of tangents PQ and PR. So here suppose point P is there. So PQ and PR, the pair of tangents are drawn to the circle. That means from same exterior point we are drawing two tangents PQ and PR. So my figures won't be too proper, but you can see just for understanding I am drawing. So PQ and PR are two tangents. This is This is 13. Radius is 5. Radius is 5. Then the area of the quadrilateral. So area of quadrilateral PQR. Now here we are getting this is point P. So let us say this is Q, this is R. So we have to find area of quadrilateral PQR. So area of PQR we have to find. So how to do this thing? How to do this? How to find the area of this quadrilateral? So what we will do here, quadrilateral means four-sided figure. Quadrilateral means four-sided polygon, closed polygon we can say. So here we have to find the area of this polygon. So how to do? We can see here two triangles are there. We have two triangles, triangle. Here if I write O, so triangle PQR is PQ plus PR is equals PR, yes. So two triangles are there. We can find the area of triangle, both the triangles area we can find and we can add them. So which property we can use? The property which we have learned. First of all, the first property tangent and radius they are perpendicular to each other. So both the triangles are right angle triangle. So both the triangles are right angled triangle. So we'll find the PR, length of PR. So again Pythagoras theorem we can use. We can use Pythagoras theorem. So we know in Pythagoras theorem, so I'm not going to solve it. We people know that 5, 12 and 13 is a Pythagorean triplet. Where 13 is the hypotenuse. So this line I have already told you the central line will be the hypotenuse. When greater side is the hypotenuse, this Pythagorean triplet we can use 5, 12 and 13. 5, 12, 13 is a Pythagorean triplet. So PR and PR is also 13. If here we use PQ is also 13. And we also know from common point, from same exterior point, if we draw tangent. So tangents they are equal in length. So that from that property also we can write PR is equals to PQ. So both are 13 centimeter. Now area of triangle. So how area of triangle PQR we can find any. So same will both the areas will be same only because the areas because the triangles they are equal. So how to find what's the area of triangles formula? What is the formula of area of triangle? Because we have to find area of triangle. Yes, it is 12, not 13 because 13 is already given to us. This is 12 centimeter. 5, 12 and 13 is a Pythagorean triplet. So area of triangle PQR. Area of triangle PQR. So what's the area of triangle formula? What's the formula of area of triangle? Area of triangle is half into base into height. Half into base into height. So half into base. What's the base here? Baseline, you can consider either this one or this one. So OR half into OR into PR. So half into so other than hypotenuse you have to consider base and perpendicular. So OR and PR are base and perpendicular. So half into 5 into 12. Half into 5 into 12. Then here we can cancel. So 5 into 6 is 30. So one triangle's area I am getting 30 centimeters square. So area of this triangle is how much? 30 centimeters square. As other triangle is also same. So area of this one is also be 30 centimeters square. So area of this quadrilateral how we will get? We'll add both the areas. We'll add this and this. We'll add both the areas. So which option we will get? So this is area of triangle PQR plus area of triangle POQ. So 30 centimeter square plus 30 centimeter square which is equals to 60 centimeter square. Is this thing clear to everyone? Option A. Option A is the correct answer. So question was simple. You just have to find the area of the triangles and add them. Let's do next question. Question number 3. Again, circle is there. So first of all, draw figures for your understanding. The angle between two radii, the angle between two radii of a circle is 130 degrees. So what is given to us? So suppose this is the center of the circle. So angle between two radii. So from center, if I draw any line on the circle, it's a radii. So it's a radius. Again, one more radius I'll draw. So two radii, between two radii, we have one angle. So that angle is given to us as 130 degree. So this is O, this is, let's say, point A and point B. So between two radii we have angle which is equals to 130 degree. So angle between the tangents from the end. So they are telling the tangent between the angle between the tangents. So suppose I am here, I have one point P. So from point P I have drawn one tangent to B point and to A also. So we have to find the value of that angle. So the angle between the tangents I have to find. So this angle we have to find. This angle we have to find. So what is the value of this angle? Yes, so 50 degree. How we can find? Just remember always this angle plus this angle, the opposite angles, the angles which is at the center and the angle which is between the tangents. These two angles are are supplementary. Here angle O plus angle P, it is equals to 180 degree. You just remember this concept. Angle P, which is the angle between the tangents, angle between tangents and angle between radii. This is angle between radii. So these two angles, they are supplementary. Supplementary means their sum is equals to 180 degree. So O we know it is 130 degree plus P is equals to 180 degree. So we'll shift to 130 to other side and we'll find the value of angle P. So angle P is equals to 180 minus 130, which is equals to 50 degree. So option B, 50 degree. So very simple question. Directly you can use this property and find the angle. Let's do next question. Question number 4. So question number 4. Figure is given to us. One figure is given to us. In the given figure, PQ and PR are tangents from P to a circle with center O. If angle PQR is 55, then angle QPR. So if angle POR, it's given to us, not PQR. So angle POR is 55 degree. So here you can see they have marked also. We have to find the angle QPR. Angle QPR. So angle QPR is which angle? This one. So this angle we have to find. So how to find this angle? Same way like we did previous question. We have to do this also. Same way. You remember here. First of all, in previous question, we considered full angles. We considered this full angle and this full angle. So here, part of that we are considering. Full we are not considering. So you remember here the two triangles we are getting. So this angle and this angle, they are complementary. So this triangle and this triangle. So I'll just name as triangle 1 and 2. Triangle 1 and 2. These two triangles, they are congruent triangles. So these two triangles, they are congruent triangles. So you don't have to prove the congruency as of now because MCQ questions we are doing. So because of this, so here I'll just write triangle OQP is congruent to triangle ORP. So these two triangles are congruent here. So if these two triangles are congruent, so this angle will be equals to this one. If this is 55, this is also equals to 55. And this angle, suppose if this is x, this is also equals to x. Because of the congruency, these two angles are equal. The angles which I have marked because of congruency, these angles are equal. Yes, so QPR is equals to 70 degree. Because in previous question, I have told you this thing, angle O plus P is equals to what? It is equals to 180 degree. So angle between tangents and angle between radii. So angle O is how much? Angle O is total 55 degree plus 55 degree. And angle P is x plus x, which is equals to 180 degree. So 55 plus 55 is 110 and x plus x is 2x, which is equals to 180 degree. If we shift 110 to other side, it is equals to 180 minus 110, so 70 degree. So x is equals to 70 by 2. X is equals to 35 degree. X is equals to 35 degree because both we don't have to find. Only this angle we have to find x, which I have assumed as x. So which option is the correct answer? Option A. Option A is the correct answer because full angle we don't have to find. If we have to find full angle QPR. If you have to find full angle QPR, then it is equals to 70 degree. But now only half part of it we have to find, that is x. So this angle is equals to 35 degree. Option A. Let's do next question now. If tangents PA and PB from an exterior point P to a, so two tangents, same type of question. So two tangents are there. One second. Yes, two tangents are there, PA and PB. So same like from like we did in previous this one. So from same point P, like this it will be. So PA and suppose here PA point is there, here B point is there. From exterior point P to a circle with O as the center is O are inclined to each other at an angle of 80 degree. Two tangents they are inclined to each other at an angle of 80 degree. So what does it mean? It means the angle between two tangents, it's 80 degree. The angle between two tangents, they have mentioned that tangents they are inclined to each other at an 80 degree. So that means the angle between the tangents is 80 degree. So angle AOP AOP we have to tell. So AOP, that means OP I have to join. So this angle's measure we have to tell. So angle AOP. So same concept we have to apply as we did in previous few questions. So angle O, full angle O, that means AOB plus angle APB. This is equals to again 180 degree. This is angle between radii, angle between tangents. So AOB, let us say again, I'll just write it as this angle as y, this also then it will be y because both of these they are equal in length. So AOB is what? AOB is y plus y plus APB. AP APB is it's given to us APB, it's given to us as 80 degree full I am considering. So this is equals to 180 degree. 80 I am just shifting to other side. So 2y plus y is 2y. 2y is equals to 180 minus 80 because plus 80 when we shift to other side minus 80. So this is 100. So y is equals to 100 by 2, which is equals to 50 degree. Yes, answer is equals to 50 degree because we have to find this angle, angle AOP. Yes, 50 degree is the correct answer. Let's do next question. Question number 6. In the given diagram, so diagram is given to us. RT is the tangent. So tangent is given to us touching the circle as point S. So point of contact is S. Angle PST. Angle PST is given to us as 30 degree and angle SPQ is equals to 60 degree. Then PSQ. So which angle we have to find? PSQ. We have to find this angle PSQ. I'll just mark. So this angle, I have marked the angle, this angle we have to find. So here what we will do, the concept which I have told you, angles in the alternate segment. Whenever you see any angle between chord and tangent, whenever you see any angle between chord and tangent, so that concept should come to your mind. Angles in the alternate segment are equal. Angles in the alternate segment, alternate segment are equal. So this concept you can see because here I can see SP is chord, SP is chord and TS is tangent. TS is tangent and we have angle SPT. We have angle SPT is equals to 30 degree. SPT or TSP you can write. By mistake I wrote wrong name. So PST you can write angle PST is 30 degree. So we know this thing angle between chord and tangent. This angle is between chord and tangent. You just have to move along the end points of the this chord. So one of the end point of this chord is S. So from S if I move and from P also if I move this angle I am getting. This angle I am getting angle SQP. Angle SQP. SQP. So you can see if you move along S and P. So here if you move along the end points of the tangent, they are meeting at point Q. So this angle will also be equals to 30 degree because this angle is equals to PST. Because of this property, angles in the alternate segments are equal. So this angle, it is between this chord and tangent. When we move along the end points of the chord, we are reaching at point Q. So this angle and this angle both are equal because our angles in the alternate segment are equal. I hope this concept is clear to you. So with the help of this, we got this angle also equals to 30 degree. So now this is a triangle. This is a triangle. I'll just redraw the triangle. QSP is a triangle. Here we know one angle P is 60 degree, another angle Q is 30 degree. So this is the angle which we have to find. We have to find PSQ. So if we know two angles in a triangle, if we know two angles in a triangle, the third one we can use by using the angle sum property of a triangle. So if this I am considering as x, so x plus 30 plus 60 is equals to 180 degree because angle sum property of a triangle. So x is equals to 30 plus 60 is 90. So 180, 90 will shift to other side. So 180 minus 90. So x is equals to 90 degree. Yes. So 30 plus 60, 90. So answer is 90 degree option D. Is this question clear to every one of you? Okay, let's do next question then. Okay, next question. Question number 7. So let's see what is given to us at one end A of diameter AB of a circle. So diameter is there. First of all, let's draw the figure. So circle, I am just going to draw. Without figures, it will be difficult. So this is the circle. So diameter AB is there. Let's mark the diameter. So diameter is that line which passes through the center of the circle. Diameter is that line which passes through the center of the circle. So AB is the diameter of a circle. So what's given to us at one end A of a diameter of a circle, diameter of diameter AB of a circle of a radius 5 centimeter, tangent XAY is drawn to a circle. So from this point, tangent is passing from A. So it's named also, this is XAY. The length of chord CD parallel to, so again there is one chord means a line which is inside the circle. The length of the chord we have to find. So here suppose CD is here, CD is parallel to, see my lines are not straight, we can, you can just, chord is that line which is inside the circle, and here they have mentioned that chord is parallel to this tangent XY. So I'll just draw one straight line here also. So this is tangent. So tangent XAY and this chord, they both of these are parallel. So the chord CD. Chord is that line which is inside the circle and it has its endpoints on the circumference of the circle. Circumference means the boundary of the circle. So the length of CD chord which is parallel to XY at a distance 8 centimeter from A. So this chord's length we have to find. So length of CD we have to find. We have to find length of CD, and this chord they have mentioned this is at a distance 8 centimeter from A. So this chord is at a distance 8 centimeter from A. So if I write here some other point, let us say any point. So we have A, B, C, D. Let's say E will write O. I'm just writing the center of the circle. So we have to find the length of CD. AE is equals to 8 centimeter. So how to do this one? So here one concept I'll tell you. If we are, see, if this is a diameter, so that means diameter is a straight line. If we are drawing, so radius is equals to, radius is also given to us. Yes, so we can join this center and point D also, because we'll get triangle. We'll join center and point D or C, any point, because we'll get triangle over here. OD I'm joining, this O to D, if I join it will be radius. It will be radius. And we have to find here DE. So just remember here. So let's join this also. So this will also be 5, although no need. So if this is 8 centimeter, if this is 8 centimeter, the distance is 8 centimeter. So AO we know. So we know here OD is radius, OD is radius. So this is 5 centimeter because radius of the circle is given to us. Also AO is equals to 5 centimeter. AO is also equals to 5 centimeter. Why? Because both of these, they are the radius. So radii of the circle. And we know this thing. We know AE. We know AE is equals to 8 centimeter. AE is equals to 8 centimeter because this is given to us. So here I can find OE. This much we can find. This part we can find. So what will be the length of OE? What will be the length of OE? It is from total AE, I can subtract AO. From total this length, if I subtract part of this much, so I'll be getting this. I'll be getting OE. So this is equals to 8 minus 8 minus 5. So this is equals to 3 centimeter. So this is equals to 3 centimeter. OE is equals to 3 centimeter. By subtraction, I have found it. Now because diameter is a straight line, so that means this will be perpendicular. Diameter is a straight line, so this will be a perpendicular line. Diameter can't be a slanting line, it is a straight line passing from the center. So that means this is This is 3. This is perpendicular. Now here we got one triangle. The type of triangle is right angle triangle. The type of triangle is right angle triangle. I'll just draw the triangle here. So in this triangle, triangle is O. So this is the perpendicular OED. So here OE we know it is 3 centimeter and OD we know 5 centimeter. If 5 is the if 5 is the hypotenuse, because this is hypotenuse only, then Pythagorean triplets we know. For MCQs I am not going to solve. We can apply Pythagoras theorem and find ED's length. ED is this. So Pythagoras theorem if you apply, we can get 4 as the length of ED. We can get 4 as the length of ED, because 3, 4, 5 are Pythagorean triplets. 3, 4, 5 are Pythagorean triplets. So once again I am just telling you, because OE is perpendicular, that's why here we are getting right angle triangle. In right angle triangle, two sides we already know. OD we know it's 5 centimeter and OE also we know it's 3 centimeter. We can find DE 4 centimeter. Yes, diameter is 10, that's correct. So we have found now ED's length 4 centimeter by making the use of Pythagoras theorem. So DE we found, but we have to find the length of CD. We have to find the length of CD. CD is actually what? CD is DE plus CE. DE plus CE. So similarly, this will also be CD, and you can just remember one concept: perpendicular from center. Perpendicular from center Perpendicular from center bisects the chord. Bisects the chord. So that means DE and CE they are equal to each other. Bisection means dividing into two equal parts. OE is the perpendicular and CD is the chord. So OE is dividing the chord into two equal parts. So that means DE and CE both are equal. So if DE is 4, CE is also 4. So 4 plus 4 is equals to 8 centimeter. 4 plus 4, 8 centimeter. So option D is the correct answer. Option 8 centimeter. Yes. Do you have doubt here, Himanshu? Are you telling me the answer? Is this thing clear? How we got 8? Perpendicular from center bisects the chord. That's why we'll get DE is equals to CE. This is 4. This will also be 4. So CD is 4 plus 4, which is equals to 8 centimeter. Let's do next question now. Question number 8. If till here anyone has any doubt in any question, please let me know. Once more. Okay, 1 second. I'll just explain this question once again. AB is the diameter of the circle. So I'm just writing O as the center. So radius is 5. Radius is 5. Here we have one chord CD which is parallel to XY. This chord is parallel to XY. So CD is parallel to XY. We have to find the length of CD. So how we will do? First of all, you remember this is because it's diameter, so that means OB it's perpendicular to CD. So OB it's perpendicular to CD. That means it will bisect the this line OB. It's bisecting the chord. So if it is bisecting here, I am writing the point E. If it is bisecting, that means this part of the chord is equals to this. Bisection means dividing into two equal parts. So perpendicular from center, only from center. Perpendicular from center bisects the chord. Bisects the chord. So this concept you have to remember. So that means DE is equals to CE. Now this is a right angle triangle. In this triangle, this is 5 and this is 3. This is 3 because this part is given to us as 8 centimeter. From 8, if we subtract this one, if we subtract this 5, we'll get it equals to 3. So we got OE is equals to 3 centimeter. Now in this triangle, if we use Pythagoras theorem, we will find the value of DE as 4 centimeter. So this is 4. So if DE is 4, we know CE will also be 4. So 4 plus 4 is equals to 8 centimeter. Is it clear now? Is it clear? So let's do next question then. The radii of two concentric circles are 4 centimeter and 5 centimeter. So two circles, concentric circles means the circles with same center. So like this. So here is one circle and here I have another circle. So concentric circles means the circles with same center. So these two circles are concentric circles. Their center is center O only. The center of this circle is O. So here I have marked center O. So one of the radius is 4, another one's radius is 5. So understood, the smaller one's radius is 4 and the bigger one's radius is 5. The radii of two concentric circles are 4 centimeter and 5 centimeter. The length of each chord of one circle which is tangent to the other. So chord of one circle which is tangent to the other circle is will be like this. So I'll just write here AB. AB is a chord of the bigger circle. If I say bigger circle, inside this one AB is there. AB is the chord of bigger circle, but where I am seeing the smaller circle, if I see the smaller circle, the same AB is acting as a tangent because it has one point of contact. So its length we have to find. What we have to do? We have to find the length of AB. So AB, which is acting as a chord for the bigger circle and as a tangent for smaller circle, its length we have to find. So radius is given to us. Bigger circle's radius is 5 and the smaller one is 4. So this is 4 and if I join O to A, this is 5 because this is the radius of the bigger circle. Now here also the question how we did the previous question, same way we have to do. We have to find the length of AB. Here I'll be just writing point C. So AB is actually what? AB is AB is AC plus BC. AB is AC plus BC. OC is the radius, OC is the radius and AB is the tangent from smaller circle. So that means OC and AB they are perpendicular. OC and AB they are perpendicular because from smaller circle OC is the radius and AB is the tangent and we know radius and tangent they are perpendicular to each other. Radius and tangent are perpendicular to each other. So that means this is again right angle triangle. So from center, perpendicular bisects the chord. The same concept which I used in previous question also. From center, OC is perpendicular from center. So that means it will bisect. If we only see the bigger circle, so OC is here. OC is perpendicular from the center, so it will bisect the chord. That means AC is equals to BC because the perpendicular from center will divide the chord into two equal parts. Now if we see this triangle, OB here this side I have taken. OA is 5, OC is 4. So what will be the length of AC? Yes, AC is equals to 3 centimeter because in right angle triangle we know 5, 4, uh, 3, 4, 5 are Pythagorean triplets. 3, 4, 5 are Pythagorean triplets. So that means AC is equals to 3. If AC is 3, BC will also be 3. So what's the length? What's the length of the chord we will get? Yes. So it is 3 plus 3, 6 centimeter. So option B. So same question like we did the previous one also is the same question. AB is equals to 6 centimeter. Let us do next question. The next question figure is given to us. It's given to us in next question. So let's see what is given to us. In the given figure, AB is a chord. So AB is the chord such that ACB is 50 degree. If AT is tangent to the circle, AT is tangent to the circle at point, then what is the value of angle BAT? So this one, what's the angle? What is the value of angle BAT? This angle's value we have to find here. We have to find the value of this angle. So what will be the value? Which concept we have to use here? Angles in the alternate segment we have to use. If any time you see angle between chord and tangent, angle between chord and tangent, if we see, so angle in the alternate segment will be equal. So this angle BAT is between chord and tangent. This angle, if you see the endpoints of the chord, they are meeting at this angle ACB. So that means BAT is equals to ACB, which is equals to 50 degree. So option C is the correct answer. Option C is the correct answer. So that was very easy question. BAT is equals to 50 degree. Let's do next question. Question number 10. In the given figure, O is the center of a circle and PQ is the chord. If tangent PR makes an angle 50 degree with the chord, then what is the value of, so this angle is given to us POQ's value you have to find. So the angle which is there at the center, so that angle you have to find. Yes, so how we will find the value of this one? So we have to find the value of this angle POQ. How we will do this one? Here one construction we will do. So Aditya is telling 100 degree. So one construction we can do and we'll see how it is 100 degree. So we know the angle between chord and tangent. So chord's end point, let's join at the center. This is the construction I am going to do because I know angle in the alternate segment will be equal. So this angle will also be equals to 50 degrees. So here let's say I am just writing one point A. So I am just drawing one angle at the circumference of the circle. So this angle PAQ, it is equals to the angle which is given to us. So this is angle PRQ because angles in the alternate segment. This angle is between chord and tangent. If I extend the endpoint, so I'll be getting one angle on the circle. So this is also 50 degree. Now in circles we have learnt one concept. In circles we have learnt one concept, angles extended by same chord at the center. So we have learned one concept, angles subtended by same arc on center is twice the angle on the circumference of circle or on the circle. So what does it mean? The central angle is two times of the angle. So here, if I just see this way, so here I have angle at the center and here I have angle on the circle. So this angle, if this is 50 degree, so central angle is 2 times of 50, which is equals to 2 times or double of this angle on the circle. So that means central angle is equals to 100 degree. So 2 into 50 we have done, we got the value as 100 degree because both the angles are subtended by arc PQ. Both the angles are subtended by the same arc PQ. So the angle subtended by both the angles are subtended by same arc. So that's why this property holds. Yes, 100 degree is the correct answer. So let's do one more question. So not MCQ, but one subjective type of question will do. MCQs, I think still we whatever concepts we have learnt in MCQs, you can get those type of questions also in subjective type, like combination, some two, three questions in one question itself. So let's do one question. This is subjective type question, 3 mark questions you can see. So ABCD is a cyclic quadrilateral in which BC is equals to CD. So its mentioned figure is also given to us and EF is the tangent at A. So angle CBD is 43 degree. It's marked on the figure also and angle ADB is 62 degree. We have to find angle ADC. We have to find angle ADC. This full angle we have to find. I'm just marking ADC we have to find. We have to find ABD. ABD. So this angle we have to find and we have to find FAD. FAD. We have to find this angle. So these three angles which I have marked, these we have to find. See, whenever you are doing questions of geometry, first of all draw figure, write what is given to us, given things you write it down and what we have to find also that also write it down. Like here what is given to us, angle CBD is equals to 43 degree and angle, so all the given things you write it down. I am not going to write it now. So you have to write it down like CBD is equals to 40 degree, then ADB is 62 degree, BC is equals to CD, all these things. Yes. So how to do now this question? First of all, we have to focus on the things given to us and what we have to find. So which is the easiest angle to find? If we see angle FAD and angle, so just I'm just writing angle FAD which we have to find. Angle FAD it is equals to angle ABD because if you see these are the angles subtended by the angles in the alternate segment. Angle FAD, so here an angle ABD. So these angles are equal. So angles in alternate segment. Angles in alternate segment are equal. That means if I find FAD, so ABD can also be found. Okay, so Aditya has given ADC. ADC is equals to 105. So ADC. So now it's given to us. So I'll use triangle BCD. In triangle BCD, because here also two things are given to us, I'll redraw the triangle also. So triangle is given to us BCD, I'm just drawing like this. So BC is equals to CD. BC is equals to CD and angle B here it's given to us as 43 degree. Angle B is given to us as 43 degree. See, if two sides of a triangle they are equal, so that means two angles will also be equal, the angles which are touching these two sides. Because of the property of isosceles triangle, if two sides are equal, then the angles facing opposite sides will also be equal because this is isosceles triangle. Two sides are equal and two angles will also be equal. So that means CD, here angle D is also equals to 43 degree. So by using angle sum property of a triangle, so here in this triangle, angle B, so full name of the triangle, full names of the angle we have to write. So angle CBD plus angle CDB plus angle BCD, it's equals to 180 degree. So CBD is 43 degree. This is also 43 degree, and BCD we can find. BCD is equals to, so BCD we have to find. So 43 plus 43 is 86. So 86 plus BCD is equals to 180 degree. So angle BCD is equals to 180 minus 86. So 180 minus 86. Okay, so D we don't have to find only. So this angle is not at all required. So this we already got. I thought C angle we have to find. So this angle we don't have to find. We don't have to find. So no, not required. Only this was required. ADC we have to find. Angle ADC. ADC is actually what? ADC is ADB plus angle BDC. BDC. So here I have angle, this is angle ADC. So if I add this angle and this angle, this is 62 degree and this is 43 degree. If I add these two, I'll be getting the total angle. I'll be getting the total angle here. So ADB is 62 degree plus 43 degree. So if we add these two, we'll get 105 degree. So as the answer given by Aditya also, so angle ADC is equals to 105. Now ABD we have to find. So angle ABD is equals to, ABD is equals to 38 degree as you people are telling. Angle CBD is equals to CDB. Okay, that also we have done. So angle ADC, yes. So ADC how we have to find? ADC we have already done 105. Yes, Shreyasi, you are telling angle ADC is 38. ADC is not 38. FAD is 38. Okay, so how we will find now FAD? So this total angle, first angle, it's done now. So now we have to, because the other two angles, they are equal to each other. So how to find FAD? You have already done, you can just F ABD is equals to FAD, it's 38 degree. Okay, so how we shall proceed towards that? How we will get the value of angle as 38 degree? You people are telling me the answer, so that I have already written also. Angle in the alternate segment, these two angles are equal. That was the first thing I did in the question. Yes, so that's what I wanted to know here. So cyclic quadrilaterals property we have to use. So because these two angles, they are equal, and we know the property of cyclic quadrilateral, because whenever cyclic quadrilateral is given to us, we have to use the property of cyclic quadrilateral. That cyclic quadrilaterals means opposite angles. Like here, if I do B plus D, so B plus D is equals to 180 degree. Also A plus C is equals to 180 degree. So sum of the opposite angles in a cyclic quadrilateral is equals to 180 degree. Cyclic quadrilateral is that type of quadrilateral whose all the vertices lie on the circle like this. So here cyclic quadrilateral is given to us. So B plus D. B is, full name I'll write here. B is angle ABC plus angle ADC. This is equals to 180 degree. So ABC again it's a mix. It is ABD plus BDC. BDC. And ADC we have already found in the first part. So 105 I'll write directly is equals to 180 degree. See, ABC is this thing. Here I have ABC. ABC is this angle plus this angle. This angle is ABD and this one is DBC. So like this ABC I have written sum of two angles. So ABD I have to find. BDC I already know 43 degree. It's given it's given to us, and this is 105. And if you simplify this, if you solve it, so you will get answer as 38 degree. You just have to shift these to one to other side. So 105 plus 43, it's equals to 148. So 180 minus 148 you can do. So ABD is equals to 38 degree you will get. And ABD I have told you at the starting itself, it is equals to FAD as well, because angles in the alternate segment are equal. So ABD is also 38 degree and FAD is also equals to 38 degree. So here we have completed this question. If anyone has any doubt, you can just tell me. Anyone, any doubt? So I guess no doubt. So here few questions I did today from tangents and intersecting chords. So in next class we'll be continuing few more subjective type of questions from this chapter. Okay, so in next class we'll continue if no doubts are there. Okay, so bye everyone. Have a wonderful day and all the best for your